One of the most important concepts in algebra is understanding the idea of different representations of functions, which means we can't just sort of have this perspective that if I get a line, I can make a graph, and it only works in one situation. We sort of need to realize that we have multiple representations and things that we can talk about and look at when we're talking about a function. So maybe if we have something like y equals 3x plus 1. Okay, one thing that we might recognize when we look at this is that this is y equals mx plus b, and so we know that m equals 3, and we know that b equals 1. But we should then also recognize, okay, that's also information that I could provide a graph of. Right? I could graph starting at 1 for my y-intercept, and then going up 3 over 1. But students kind of lose and forget the pieces we talk about that happen in between there, right? This line represents all of the x and y values that make this function, this equation, true, which means there's a table of an infinite amount of values. You could pick any x value here that you want and find its corresponding y value. So if we just pick some simple numbers, right, these are numbers we could plug in and find their corresponding y values. So we're going to plug in 0 for x. So instead of saying 3 times x, we'll say 3 times 0 plus 1, which will give us 1. Right? If we plug in 1 for x, so 3 times 1 plus 1, which gives us 4. If we plug in 2, 3 times 2 is 6, plus 1 is 7. Right, we could kind of do this as long as we wanted. Okay, but these actually represent ordered pairs. So this is the ordered pair 0, 1, right? And if we look at our graph, 0, 1 is right here. This is the ordered pair 1, 4. That's our second ordered pair that we plotted here. Okay, we know that because this is in y equals mx plus b form, that this will make a line. But that concept holds true for anything. So we can graph things that maybe we've never seen before. So things like y equals x to the third, right? Maybe you've never dealt with an exponent of 3, but that doesn't mean that you can't make a table and start getting some input and output values. So if I plug in 0, I want 0 to the third power. If you don't know what that is, it's taking 0 times 0 times 0, right? Times itself 3 times. As the numbers start to get bigger, you might want a calculator. You can enter any exponent with this up caret, these two sides of a triangle. So you hit 0, up caret 3. I mean 0 times 0 times 0 is just 0. Right? If we plug in 1, 1 to the third power is 1. 2 to the third power is 8. Okay, maybe if we started to plot these. So we'd have 0, 0. Maybe I'll do these in between here to give myself space. 1, 1. 2, 8. Okay, that gives me a little bit of the picture. Maybe I need to see more of what's happening over here since I've never graphed this before. So I could plug in some negative numbers. Now be careful, you need to put this in parentheses to get this in your calculator, right? Because you want all of negative 1 to the third power, right? Or you could take negative 1 times negative 1 times negative 1. Okay, negative 2 to the third power would be negative 8. Negative 3 is going to give me a really big number that I can't fit on here. Okay, but I could do negative 1, negative 1, negative 2, 8, right? And I can sort of see that this is giving me this graph that sort of goes like this, right? I can get that same info by putting all of these pieces together. So you're gonna look at a task that sort of has you do the same thing with some familiar things and then maybe some things that are less familiar by making tables and looking at the graphs.